All right, so here's a few that I thought were interesting. So yet again, somebody has decided to publish a paper saying women are inferior to men. This is really not a good political move these days. But every couple of years, some scientist publishes this. And this guy, I don't even think he did any work. He just went through a list of other people's papers and tried to add it up. And he claimed that women don't have any less chance of getting promotions or anything than men, and they must therefore just be inferior or something. So of course they publish it. Now everyone's screaming and yelling and saying you shouldn't have published it, and he doesn't know what he's talking about. So anyway, this reminds me of another guy who's reappeared who got fired from college after college for saying the forbidden thing you should never say. This guy is obviously the same category of somebody that just says something that everybody knows. You can't say things like that. I don't think I know that person.
Yeah, he was Harvard.
Oh yeah, there was a guy at Harvard that published it. There was a mathematician. Yeah, there are people who do this every few years. There's somebody that published stuff like black people are inferior. There's a bunch of people that publish things like this, which. Yeah, and I guess Yiannopoulos, the Milo Yiannopoulos from Breitbart, he was a similar guy just saying stuff like this, which I guess if you just go on the right, if you're a Republican, I guess it's okay to say all this. But if you're an intellectual or something, then it's totally not. So you should just like move to Florida and join Trump's team, and then he'd probably be fine. But if you want to be a scientist, you can't be saying things like that. So this happened again. This is like third or fourth time I heard of this. Best Buy sold a bunch of smart home gear, and they decided, oh, forget it, we're turning off the servers today. So all your smart gear is going to just stop working entirely or become dumb. This reminds me of, I think it was Walgreens sold a bunch of DRM music, and a few years later said, oh, this DRM is too much bother, we're turning off the servers, so all your music will stop playing. So you have like 3 months notice, and here's some link to some illegal hacking tools you can use to strip the DRM off your music. And if you don't do that, it's going to stop playing. Many, many people do this. And this is kind of what the haters always said when you started having DRM and smart devices and everything. Wait a minute, what if they turn off the server at the other end? And it also, the big thing, not Linus Torvalds, the Mad Monk, Linux guy. GNU Unix. Richard Stallman.
Yes.
Richard Stallman hates all this, and he hates the Amazon Kindle and calls it a swindle because he says you don't really own your book, which of course is true because at least once Amazon did reach down to everyone's Kindle and suck a book back because they sold the book, and I think it was Brave New World, and they didn't have the rights. So to fix it, they remotely deleted it from everybody's Kindle. And so they can do it, and I think Apple and Google can both reach onto your phone and delete an app after you put it on there, and they have done it occasionally. They just don't do it very often. But in principle, you don't really own that stuff as if it was a book on your shelf. Anyway, that's getting fun. So apparently Iran has continued to kidnap people for political reasons all along. I saw it the other day. It's pretty good. We've been doing more and more of it. It's interesting to see. And, you know, this is kind of one of those things where Trump kind of has a point when he says, you know, making the Iranian hostage, making the Iranian nuclear deal and pretending that these guys are like civilized and good neighbors is kind of a problem because they're seriously nasty people, the way they run their government. You know, of course, just pretending you don't have to deal with them at all is not so good. And what he's doing now is they're going to keep on doing this and have nukes as well. So I'm not sure he's made an improvement, but of course he's kind of right that they're not exactly a civilized nation that plays fair even now.
They just grab people inside their country, right?
They grab foreigners and hold them hostage to get things. That's a lot. Russia's been doing it all along too. I knew scientists myself who went to.
Doing the same thing.
Who does?
Every country is doing the same
No, I don't think the U.S. kidnaps foreigners who come here to visit to extort something out of other nations. I'm not aware of that happening.
The U.S. grabbed people from terrorists. You know,
Well, sure. If we have a particular crime accusation against that person, we'll grab them. But I mean, what these guys do is just make up charges against random people and grab them.
they did something else because those people did something else. The government did.
Well, actually, this is of course a matter of interpretation. It seems to me like they just grab random people, but of course they do.
It's not random. China is doing the same thing.
Yeah.
Whoever talk back about them in other country, once they get into China, they grab them.
Well, it's a very interesting issue. I know when we went to DEF CON China last time, everybody I talked to at DEF CON China said, all of my friends freaked out and said, oh my God, don't go to China. They'll arrest you or kill you or something. China's a terrible, dangerous place. And we all felt like it wasn't that dangerous at all. because we felt like we knew what not to do.
Once you talk bad about China inside this country, but once you get in China, they ban you.
Well, I wonder, but anyway, it's a very interesting issue, and of course, they will say that these people did something wrong, and it's hard to say. I remember I made myself very unpopular at a Secret Service meeting. At a Secret Service meeting about a year ago, the High Tech Crime Investigators Association. They were real proud of the fact that they would now cooperate with Russia, and they could now get Russia to send them evidence so they could arrest international criminals that were doing like cyber attacks. And they said, we can now get evidence by cooperating with the Russian police. And I raised my hand, and they tried to ignore me until they couldn't. When they asked me, I said, how do you believe something you get from Russia? You know they just make up lies there and frame people. So why do you believe it when they give you evidence? They say, oh, no, it came with a signed affidavit. It must be okay. And I'm like, that doesn't really satisfy me. And they're like, shut up, kid. But, you know, they worked for years to make this partnership, and they don't need people like me. But I said, how does it meet the standard of reasonable doubt in an American courtroom when the Russian government testifies to something being true? That doesn't really convince me very much. Anyway, so if you're in the UK, you have to register your drones now for £11 or £9. And if you don't, you'll have to pay £1,000 when they catch you, because the drones are a hazard to navigation and they're fed up with it. So you have to have like a drone license. As far as I know, the current situation of drones in this country is you cannot use them for any commercial purpose at all, because they still have not decided what the licensing would be, what the lanes would be, how the cops will arrest them and take them down. And until they've done all that, you can only use them as hobbyists. And so there is a black market of people that will do things for you with drones, like fly around the fences at your farm and see if there's holes in it, and it's all illegal.
Those people, they're like doing, movie shooting, and they get a license to pay a fee.
Yes, I wonder if that's true. Last thing I saw was about 2 years ago. There's an article saying, in fact, there's a bunch of people that want to use drones, and all of what they're doing is technically illegal right now, because nobody has decided yet what license you need to drive a drone, what the rules are, how fast it can be, or anything. Yeah, well, it would be interesting to know if it's gotten more legal. There's a bunch of people doing it anyway. But it was yeah.
What's the federal guideline on how to use it?
Well, that's the problem. Since our government's been paralyzed for at least 5 or 6 years, with the Republicans and Democrats hating each other so much they can't cooperate on anything, we really haven't been able to pass any legislation about anything, really. And this is one of the many issues that's just hanging fire. Anyway, so this is an insider at Facebook. I was very interesting, who was supposed to stop their corruption of politics, and she found out that it's just what everyone thinks, that they don't have any interest in doing this at all. They hire people to give them a title to make it look like they're doing something about it, and then they just tell them they can't do anything and shove them in the corner until they get frustrated and quit. And there's a whole bunch of people coming in like that. They just hire someone to like whitewash their practices, but they don't actually change anything. So we'll see what happens. If the Democrats win, they probably really will hurt Facebook, really will break them up or force them to obey something like GDPR. Supposedly California's privacy law is coming out starting next year, and that would perhaps affect the way Facebook sells all their data from California. We'll see. So I was amazed by this. The CEO of McDonald's got fired and blacklisted for 2 years from the industry for having a consensual affair with a subordinate who was not complaining. It is, I'm just amazed at this punishment for what seems like a relatively minor crime. Yeah.
And how much of a subordinate was the person? Because if they are subordinate, and he's
Well,
the CEO, then
the company policy is they can't be in your chain of command. And I think if you're the CEO, that's everybody, but I don't really know. But I mean, what Liz said this morning when we talked about this, which I think is inciting, probably he did something else horrible. And this is just an excuse. What's that?
It's not a minor crime.
It's not?
No,
I mean,
How can it be?
at colleges, I mean, it certainly violates company policy. It's not a crime, not a crime at all.
You said it was a minor.
Well, it's a minor offense. It's a minor violation of company policy. But you're right, it's not a crime at all. That's why it's amazing to me that you would do this kind of punishment. I think you'd just like make him pay a fine or something. Yeah.
Probably you guys more to the inside.
Yes, that's what I'm assuming.
Probably this side.
That was my thought. They probably hated.
Probably this side too, like a instructor or something, and then somebody complained.
Yeah, they probably wanted to get rid of this guy, and this is just the excuse. I know when my Russian friend said when Clinton got pushed out.
McDonald's doing quite well at the top, so he's
Yeah.
doing okay at job.
Yeah, but I mean, when Clinton got impeached over Monica Lewinsky and Alexander Haig stood up and said, I'm in charge, my Russian friend told me that inside the Politburo, they thought there had been a military coup and the president was dead. And this story about him having sex was just a cover story. And that's the feeling I have here. That can't be the reason. this is the cover story. There must be something else going on. Anyway.
Alexander Haig during Bill Clinton? Somebody else had a heart attack.
Yeah, I thought it was him, but somebody see one of the military guy did stand up at a crucial moment and say, "I'm in control," and that made people think there'd been a military coup. Yeah.
The relationship is consensual. Why put it out? I mean, somebody has.
I know. I mean, well, yeah.
Can you really have a consensual relationship if you're the CEO and you have a subordinate? And if you're the CEO, you're saying, I want to have, sex with you. I mean.
Well, suppose you're Donald Trump and the other person is anyone on earth and you're way above them in power. I mean, there's inequality of power frequently. I think you just not reproduce the species at all if you ended.
No, maybe, but that's what happens like he's the
well, sure.
president,
Check.
was like,
well,
this intern, like, hey.
Well, that was the issue. I mean, I understand it at colleges. You're not supposed to have sex with students because the parents send their kid to school and hopefully you're not going to corrupt them and stuff. But anyway, it's an interesting issue. I know it happens in all the colleges. I hear rumors it happens here a lot.
Someone internal or a group of people internal.
Anyway, so let me go on to the official stuff here. We didn't quite finish the last chapter last time, so that's the first order of business, is to talk about this kernel debugging. And then I'll talk about the projects because we've got kind of a tricky situation there. All right, so we talked, yeah.
I think it was Cahoots from this class last week?
No, I think it's a different class. Yeah.
Thursday, right?
Yeah, I think so. Yeah, there's some Cahoots missing. Yeah, from the new class. Yeah, from Thursday, I think. Anyway, so kernel debugging, we talked about some issues of kernel debugging, and we've got to talk about more, and this is going to lead to my current difficulty with the project. So if you're in userland, then it is hard, and if you have a rootkit or something running in kernel land, and you want to do something from kernel space, it's kind of hard to do. Normally you write to a file from userland. Writing from kernel land is actually kind of backwards, and so you have to do weird things. You can't call user mode functions like create file and write file. You have to go down and call the lower level functions NT, create file, NT write file, which are the things that can run from kernel mode. So that's a little weird. So here's user space code, which will create a service. So it's going to call the create service function, and up here it's got a, let me make this an intermediate size so I can point with my mouse. All right, so here you're calling create service, and remember this is assembly code, so you push a bunch of stuff onto the stack. All these are all the parameters, and so up here you launch a service of some kind, and now that you've launched a service, then you can get a handle to a device object in user space. And then you're, once you have a handle of the device, you can use device IO control. Anyway, there's a bunch of stuff you have to do to make these calls to run user mode code from the kernel, which is kind of backwards. So anyway, you can watch kernel mode code. You can even watch all the kernel modules load if you like. Kernel modules load, in Linux they call them LRK or I forget what they call them, things that load during run. You can load drivers while you're running, of course. If you plug in a USB stick, for example, then it has to load a driver to load the USB stick unless you've recently plugged in a similar USB stick. So you should only see things load when new hardware appears. So if you are downloading some file from the internet or opening a web page and suddenly another kernel module drives, that's pretty bad. That probably means you got infected by rootkit. It's putting in a fake driver. So anyway, one thing that does happen in VMware is this K-mixer thing keeps loading and unloading. That has got something to do with the way VMware simulates hardware. So that would be one thing that looks suspicious but isn't. Anyway, so here's kernel mode code. If you go to driver object in debug, in WinDebug, you can see this thing here. And it'll show you have a driver object loaded. And you can do DT, which we've done before, to look at the structure of the driver object. And here you'll see the structure of the data structure of a driver. And here you have the actual contents of the driver. So you have the code numbers that are associated with it and the driver's name, which has this Unicode string. You make it look like a file writer. So that's the kind of thing you'll do. And it'll eventually create a file, DOS devices C secret files.txt. So this is a fully qualified object name. This is not the way you normally see a path, because you're normally running from userland, and the root of everything is, you don't have to include the root, you can start at C, but if you're coming from kernel mode, you have to use this kind of path. And if any of you remember good old days of Windows XP, there was this thing called boot.ini, and in the boot.ini file, there were paths like this referring to which disk and which partition on which disk to boot from. This is a fully qualified object name, which you don't see under normal circumstances from userland, but you do see if you have to reach an object on a hard drive without already having an operating system running on one of them. So it's just kind of the same situation from the kernel. You don't have the environment that you normally have from user land. So anyway, applications work with devices, which are in user land. And so you look at the user space application to find the device object. Then the device object points to the driver object in kernel mode. And you can see those with device object and device handles. So all that is true, but the main thing for us, that's all how normal Windows works for normal drivers. But for us, of course, the interesting thing is malware, and this is what rootkits do. Now, there are user mode rootkits that live in user land like other programs, and therefore they're not really that deeply embedded in the operating system, and they're not really that hidden, and they're not that hard to remove. The really cool stuff is kernel mode rootkits that change the kernel of the operating system, so all the fundamental API calls are now altered and do something wrong. Those things can be really hard to find. That's the point. They can hide processes and everything, and they can be hard for antivirus to find, and so on. And the most popular method in at least before Windows 64-bit versions was the system service descriptor set hooking. So the SSDT is one of the many tables of indirection. And if you take 127, we talk a lot about this. We hit the hooks that are used to call C library functions. If you want to call a C library function like printf from a program, you don't jump right to the library code printf, you jump to an offset table in your program, and then an offset table in the library in the operating system, and then to it through two levels of indirection. And that way, each module, the program and the operating system, can be updated without the other one being updated. So it goes through a level. So if, for example, if I update my operating system by putting on a patch and they change a C library function and move it to a different location, they just change the entry in their offset table, and my program goes to the place where it used to be and finds it, because that's just a pointer which they moved to a new place. And the same thing can happen at the other end. I can recompile my code and it won't lose it. So rootkits have the same issue. You don't jump directly into the kernel. You jump to a table of offset locations, which then points to the methods in the kernel. That way, Microsoft can update it and change it, and your programs will still find the kernel objects where they expect to find them, sitting there in the SSDT. It'll just change that value to point to the new location of it. This is really important. Otherwise, you would not be able to update an operating system without breaking all the installed programs. So this SSDT is designed in the kernel by Microsoft, of course, and there are three ways to get in here: syscall, sysenter, and int2e. They're all around, but sysenter is the modern technique. Those other ones are older techniques used in older versions of Windows. They all amount to about the same thing in practice. So here's ntdil.dil. This is nt create file function. So what it's going to do is move 25, which is the code for nt create file in here, and then move this value into edx, and then call this location, which will go to that address and then return. So this will move a parameter of 25 and call this address, and that will then call the correct function. That's the little code that does it. It'll go to this instruction. So that's the game. And you have these SSDT table entries. So you just have a whole series of entries, and they're just pointers. 805B, 806, 8060, these point to all these things. So if you wanted to do something like nt create file, you would not try to find where it is. You would just jump to the pointer to it, which is always in the same place. And this pointer will always point to wherever it is right now. And if somebody updates their Windows, it will just change this pointer, but it won't change its home. So your programs will still find the new version of this function. That's the game. So all you have to do, for example, is the rootkit can just change this value. And now everybody that tries to create a file will in fact go to some other code. And you, for example, might want to not make it possible. You want to make a hidden folder full of some kind of malicious stuff like a crypto miner, and you don't want the user to be able to delete it or even see it. So you'll make it so create file never lets you create a file in that folder, and you'll make it so read file and open folder never lets you open that folder and never lets you read the files in there, and the directory command never sees it, and then the antivirus will never see it. When it tries to scan it, list all the files and folders, it won't see it. If you successfully hook all the calls that are used by software, then that software will never find the thing you're hiding. And of course, if rootkits perfectly did that, they'd be almost impossible to detect. Anyway, so that's the game. If your rootkit calls the original nt create file, then it removes the files it wants to hide, and then it hooks it. All right. But if you use the dir command, nt create file won't do that, because dir, of course, doesn't use create file. You'd have to find what API calls the dir command does. and you'd have to hook enough up. So you can totally catch this very easily because the SSDT should point to real kernel routines, and the kernel is small. It all has the same addresses. So it's pretty obvious. So here in the Windows 2008, this is the command DPS KI service table. If I do that, you can see all the, this is the SSDT. So this is just counting up 4 bytes at a time. These are just 32-bit words, so 70, 74, 78, 7C, and these are the addresses. And so it points to all these NT kernel functions. And you can see they all start with 82 because the whole kernel is pretty small. So all the real kernel addresses are in 82. And if you get infected with a virus and it modifies it, then you have 80, 80, 80, 80, and then F7 in the middle of it. So this is the one the bad guy modified. That is clearly not a genuine Windows kernel call. It's going somewhere outside the kernel. So this is actually very easy to catch. All right, and so you can find LM will list all of the drivers. And if you have a malicious driver, then you'll be able to find it. So here's what the hook function would look like. You now jump to the original NT create function for some requests. So what you do is you do some kind of test, and you either go to the real NT create file or you don't. So you test like the folder name to see if it's equal to the folder of hidden stuff. And if it's not, then just let it do the normal thing and otherwise do something different. That's all. So your hook doesn't really do much, but that's how you hide something. Now there are interrupts around here too. So which interrupts are emergency calls for something to happen right away, so the processor has to stop whatever it's doing and go do this other thing. And there's an interrupt descriptor table that specifies these things. So here's a sample interrupt descriptor table with a whole series of addresses pointing to different locations. So you have a whole lot of interrupts in modern systems. I remember in the days of MS-DOS, there was only like 5 or 10, and you'd have to change switches on the motherboard in Windows 95 to add a new piece of hardware. There's still a lot more interrupts now, but still they all do normal things. And if they go to something other than a normal Windows API call, then that would be suspicious. These are all calling things like API handler and call interrupt and broadcast call service, appropriate Windows functions. So you can load a driver. There's a special tool you can download that will let you load a driver just to test it. And then we get to the real thing I wanted to tell you here. So I mentioned boot.ini is what we used to use in Windows XP. And in 64-bit versions of Windows, Microsoft finally got fed up with this nonsense, and they put some real kernel protections in place. And one of the strongest protections they put in there was PatchGuard, which stops third-party code from modifying the kernel, and the other one is requiring all drivers to be signed. And the idea was this would end all kernel mode rootkits because you would have to have a trusted signature, which would be verified with like an HTTPS signature on the internet. So they would have to be from a real company they can track down and sue, and you'd have to know who wrote that driver for it to go into the kernel. That was the plan. And so the idea was here, the driver signing was going to end kernel mode rootkits. And that's what people believed for a while. And it stayed that way for a few years, but now they have come back. And there's a new technique made long after this book was written. And I got a book today about it called Bootkits and Rootkits. The new technique is you store the new modified kernel files on the disk, and then you modify the boot records, and then you cause a blue screen of death and force it to reboot. And now it boots in a modified way and turns off this protection and loads the poison drivers. And that's what really happens on modern machines. And by the way, it's very much like the new iPhone jailbreak, which did the same thing. They couldn't get into the running iOS model because it's all encrypted and protected, but the fundamental bootloader had a vulnerability, so you could reboot the phone with a modified bootloader and modify the system and get it running under your control. So I'm hoping to give you that project. You can, so the main project you do to practice this stuff, I made it extra credit because I really don't want to waste too much of your time on an old dead system. Windows 2008 is deprecated, but you can do this if you like in this one here, 4.4.11. SSDT hooking, but you can only do it with Windows 2008. Now I was going to port this to Windows 2016, but these techniques do not work on Windows 2016 64-bit. So I'm hoping to find some stuff. I've got a couple of blogs to go through, and I'm hoping to give you a project that shows the modern ways you do this on modern systems. But that's really quite new. And so you can do this on your 2008 server, and it's like my slides have. You can load this thing in 2008, and then you can see the SSDT. So nope, they're still going to the wrong one. See if I get this thing to go to 4.11. I may have to use a different browser. Looks like I am going to have to use a different browser. Once some browsers get the idea that it's wrong, you can't get them to knock it off. There. It's really there. What's that?
What are you using?
That's Firefox, but I find this with all browsers. You see, I first downloaded the page once before I uploaded the file. And if you upload the file, it refuses to check again. It keeps on believing it's in the old place for some long period of time. It's very annoying. Anyway, browsers have like a thing called clear cookies or something, and it hasn't worked in years. Once you get something wrong, it will stay wrong for a really long time. That's why I have so many browsers. Every time I make a mistake in my web page, I fix it. I cannot see the fix in the same browser. I have to go to another browser to see the fix unless I want to wait like a half hour. If anybody could teach me.
The search bar history, because that's hard. It never goes away. Even if
you can get that in the registry on Windows machines. I don't know about other machines.
I was talking about iOS. I'm saying Safari.
Yeah, I don't know how to do it there. Yeah. Anyway, so here's the game. Here's the SSDT. You can do this command, DDS Chi service table, and that will show you the SSDT on a Windows 2008 machine. And here's a clean SSDT, so all the numbers point to the same area, in this case, 81. Now, you can print it out. And by the way, since I loaded my WinDebug and it got the Microsoft Windows symbols, that it does have this descriptive phrase here to make it easier to understand what you're doing. It knows what the name of it is for known things like NT add boot entry. So you can save a log file with these commands in the debugger, and then you'll get a notepad file that lists all of them, and there are hundreds of them. These are all the kernel modules. Now you can install something that modifies it. Here's something some researcher wrote years ago just as a test, something that puts on an SSDT hook. And if you do that, then you'll see some parts of it get hooked, and you can see obviously right here, two things happen. It has a number that's obviously wrong, and it's not a known Microsoft symbol, so the debugger can't figure out what the name is. So it puts an error message there, so this makes it very easy to spot. It doesn't know what this is, it knows what that is. And so you can now compare it to your log, and you can find out what got fixed here. And it was delete value key got replaced by something else. So you can find 4 objects that got hooked, and that's the flag, is to find the 4th one. And then zone alarm. This is how all security products worked until about 8-10 years ago. They worked by hooking, because your security product has to mess with the operating system. Like you load a floppy, you double click on a file, and it has to say, wait, before you open that file, I have to scan it. They did it by hooking the kernel, which is why Microsoft got such a bad attitude. Antivirus kept modifying the kernel, and that means Microsoft can't tell a legitimate antivirus product from a kernel mode rootkit. They're both modifying the kernel. That's why Microsoft doesn't like this and tried to prevent it. And they had a big legal battle with the antivirus companies over it. But anyway, you can download an old version of Zone Alarm, and it will also do the same thing, put in a bunch of hooks, and you can see them in there. So I'm hoping to give you a similar project in 2016, but it's all changed a lot and gotten more complicated, so it's taking me some time to write a good one there. I could even add another course in that, in like reverse engineering. There's a whole book in modern rootkits and stuff. It might be worth doing, I'm not sure. But anyway, I'll try and get at least a project or 2 added. So I made that one extra credit because it really is only applying to an out-of-date version of Windows, and that's not that important. I should mention, by the way, I just added another extra credit project, which you might want to do, which is extra credit because it's not really on topic, but I'm real happy with it, so I threw it in here anyway. In case anybody feels like getting more points, I put go the wrong way here. I'm going to do this at B-sides if they approve it and all over the place. This teaches you Go. So I have 4 projects, and I'll be adding more. These are challenges to solve little hacking puzzles and learn how to program in Go, which you can totally do on any Linux machine, in principle on any machine, but I only bothered with Linux. I didn't bother trying to get it to run on Windows because I had the experience of making Python run on Windows, and you might as well just hit your head against the wall. So I highly suspect it's the same with Go. Just put it on Linux unless you enjoy suffering. But anyway, you can learn basic Go there if you like, and it's worth extra credit in any of my classes. Yeah, you can do it anywhere. Why not Python? Oh, well, I already did Python, but I did Python 2.7. And Python 2.7 is ending, so I thought I might update that stuff to Python 3, but that's really boring. And everybody's saying Go is cooler than Python, and Python is old and slow, and we should all be learning Go. And I said, well, let me take a look at Go. And Go is pretty cool. So that's what I was motivated to do. Yeah, Python is what I used to use, but Go is supposed to be much faster. Go is really compiled. So, you know, it's also much more modern. You have this folder structure and module structure and stuff. So it's a much more modern language, so it's a good thing to learn. But of course, you can totally do all the same things in Python or any other language, but it's just the way I thought it was fun to learn Go. Anyway, so do that if you like. If you want extra credit in any of these classes, or if you have any interest in learning Go, Go is the new hotness. Anyway, I've got some Kahoots about that someplace. It was time for something. That would be in this browser because I cannot open Kahoots in Brave. I switched to a new browser, and of course, there's always something that doesn't open. So anyway, Cahoots work, but it doesn't understand Google logins. Something's wrong with the OAuth or something. Anyway, 10D, this is the one. So until I figure out how to make Brave do it, I have to open my old browser, Firefox, to get Cahoots to run. I ditched Chrome because they tricked me into logging in and synchronizing across my devices, and I ditched Firefox because they bothered me with political ads on Twitter. Brave gets rid of the stinking political ads. And the political ads that offend me are the ones from my party. They advertise that my party is just a bunch of corrupt crooks trying to lie to people, and that really bothers me, but that's the way it is. Yeah, I don't think we have a chance to vote for Pelosi. I think she'd make a good president. I think but she promised not to do that. That's how she became speaker, by promising never to run for president. And she might be so ethical as to actually obey that promise, which I would be kind of a shame. She hasn't read her Machiavelli if she does that. Machiavelli explains about political promises. Political promises should only last as long as the reason you made that promise lasts. Then you just throw them in the wind and do what needs to be done. Anyway, we'll see what happens. Chrome all the way. Yeah, I used to use Chrome a lot. Then Chrome tricked me into logging and synchronizing junk across my devices, and I felt very offended, so I went to Firefox. Well, Firefox didn't do this synchronizing garbage, but Twitter was all full of really offensive ads, and I was always getting mad about the ads. And my sister told me years ago, you just use Brave, it gets rid of the ads. And I said, well, it's time to see about Brave. And Brave really does get rid of all the ads. And if you block the ads in Firefox with an extension, all the news sites won't load. Everybody says, oh, no, you have an ad blocker turned on, but Brave somehow fools them. And you can still get rid of the ads, and you can still see the page. It's awesome. Yeah, yeah, it's really nice to get rid of the stinking ads. And somehow, the sites don't catch you the way they do in Firefox. Probably because nobody's using it. You know, a small one, they don't bother to detect. Just you have to keep jumping away from the popular ones to the fringe ones. Like I use Opera a lot. And that's another one you can use if you want to confuse all the web servers. Nobody uses Opera. To use these 1% ones, it's like voting for the 1% candidates. You're in your own little island. Anyway. Opera, they all do about the same thing, but in subtleties they're different. Anyway, so, okay, which module is loaded and unloaded by virtual machines?
I mean, technically, some other ones loaded in virtual machines.
But they're not often loaded and unloaded. This is the most.
I would argue NTDLL is usually in Windows CMs.
Oh, it's in there, but it doesn't keep loading and unloading. It just wants when you put it. Yeah.
Unloading. Okay.
Yeah, okay, that's right. All right. So what's the normal function used by Microsoft components to execute kernel code? It's now sysenter. Syscall and int2e are the old-fashioned ways. Modern code uses sysenter. They all do about the same thing. Anyway, what's the most common object altered by rootkits? Okay, that's the SSDT, of course. All right. Which one of these is not used in Windows 10? Okay, no boot.ini, that went away with Windows XP. All right. And which one do you have to use if you want to put unsigned device drivers in 64-bit Windows? It can be done, but you have to change the Windows. You have to switch to no integrity checks mode, which you also use BCDedit for, but this is what you need. That's the flight switch that turns it off. And you'll probably be doing that in this project if I get it going. So vote for Pelosi, I assume is probably you. you're the most likely to have a name like that. And Juggernauts, is that you? Okay,
That's
maybe.
Ed. I was,
You think that's Ed? It is Ed, yes. Okay, good. And WITB, you know who that is? All right.
I was the Chrome username.
Okay, fair enough. Good. Well, I've recorded the scores, and so now we can go on to the next chapter and at least start this. We may not finish this today. I don't really want to push it too far, but let's see what we do. So now we get down to malware behavior, and this starts out easy and then gets into some sort of dense stuff, but this is actually very important stuff. So you got downloaders and launchers. Now, downloaders are little programs that then connect on the internet and download something else. So normally they'll use something like a Windows API call, like URL download to call. They'll download something and then run it. Most malware is staged. You put a little thing on, it loads a little more and a little more. Then there's launchers. These are things that sneak executables onto the file. And I did a bunch of this years ago in Python, a whole series of projects, Python versus Norton, where you sneak malware in. This is a technique from the Violent Python book, and it still works. All you have to do is put an executable code in the data section, like a string variable, and run it in, and then you write a program that will load it in memory and execute it. Just like the test programs we have that test shellcode that you write, and that apparently fools antivirus. Antivirus is dumb enough not to look for the pattern of bytes, but to look for the pattern of bytes in an executable file. And if it's just in a variable, they figure it's okay. So that's fairly common. You have an extra section of this, like a resource section, that includes a second program, and all the launcher does is load up that program and run it. And then you got backdoors, of course. These are things that give you some remote control of machines, so they create a new administrator account or a listening port or reverse shell or something like that, and give you the ability to control the machine, manipulate the registry, run programs, and so on. Reverse shell is by far the most common because most machines have the Windows firewall turned on, so they will not accept unexpected incoming traffic. You have to initiate the traffic from the target, which will then call out to the command and control center, and that's the way it works. So you can do this with call create process and then create a socket, which will then tie the socket to the remote machine. That's one way to do it. You can do these things in command line on Linux with things like netcat, and in Windows, of course, you do it with API calls. You can make a multi-threaded socket, 2 pipes and 2 threads, one to send data out and one to send data back in. If you're in Linux and you make a netcat shell, you may have seen this, you have to run 2 of them. There's one pipe you often use 2 ports, 1 port for outgoing traffic and 1 port for incoming traffic. It's often not 2-way on the same port. So remote administration tools work like this all the time. So you'll have clients going to servers and then actions coming in. Anyway, I'm not quite sure how this thing works. Yeah.
So what exactly is Poison Ivy?
Well, Poison Ivy is one of the famous rootkits. Like Back Orifice, Poison Ivy is one of the big ones back in the days of Windows 2000 and Windows XP. It was one of the big ones that everybody used. There were people that actually made these and sold it commercially. And I think Poison Ivy might be one of the ones that was sold commercially, and the guy actually got in legal trouble for it. But now they sell them all the time for parents to use to spy on their kids and bosses to control their machines. But there are also people that sell them just for bad guys to use. And in fact, a lot of malware uses ones from Metasploit and elsewhere, which is why some people say you shouldn't write hacking tools like Metasploit. It's just a remote administration tool, just a rootkit that was set on the machine. This one I think wasn't even a rootkit, but just a program, a piece of malware that you protect the machine with. Anyway, so you make a botnet, you have a command and control center, you control a bunch of machines, and so the botnet contains many hosts. The rats typically control fewer hosts. Remote administration tools are actually supposed to, like TeamViewer, are supposed to use under your control to control the machines, so you have permission to use them, like you run a tech support company, you use TeamViewer for your customers, but the bad guys build it into malware and then put it in spreading viruses and infect a lot of machines. Anyway, then you got credential stealers, things that try to steal the credentials off the machine. So one thing you can do is wait for people to log in and steal the keystrokes. The other thing you can do is try to steal stored data. Now, modern versions of Windows, of course, no longer store passwords in plain text, although Android apps really do. But Microsoft has pretty much learned around the days of Windows 95 to knock that off, and so they store password hashes. And so if you do steal hashes, then they're hard to get because there are internal defenses to prevent you from getting the hashes, and after you get them, you have to crack them. However, there are other ways to log in, more and more these days, thumbprints, facial recognition, and so on. And in Windows XP, this started with Gina, graphical identification and authentication. This was Microsoft's generalization of the login process with msgina.dil, so it could connect to some other device, like a fingerprint reader or a facial scanner or something, and you could then have that object do the logging in for you. This is an improvement over the previous system I often mention, which was something Apple and Microsoft both did, with a USB thumbprint reader, which would just have a list of your passwords in plain text in the software, and then it would type in your password for you. And they figured out that's a miserable idea. So they updated that to Gina, which can take biometric or other things as information to log in. So Gina has a registry key. This contains the third-party DILs that have to be loaded every time you boot up the machine so it can be ready to do this. Now it will load the Gina DILs, and then the Gina DILs will own the libraries that can supposedly collect some kind of information from this other login procedure and decide if you're authentic. So what you can do is make a malicious DIL that exports these functions, and then it acts like a man in the middle. So now when the login process thinks it's calling the MS Gina API calls, it's actually calling your malicious library calls and letting people in without actually having the right authentication procedure. So that's one way to do an attack on Windows XP. And so you'd, all right. So here at 2, it would call log to file, and the malware would now log the credentials. So this would capture the credentials from this third-party system, sort of like a keylogger, but stealing authentication information. However, Gina is gone. I don't know why, but it doesn't matter, because Microsoft just put the next functionality, this new thing called Credential Providers, which is even more general to have more ways to prove who you are, as I'm sure to deal with enterprises and other things. So you have several registry keys in here about these credential providers, which amount to about the same thing as Gina. There is some way for a different process to be used to decide that you're okay. And they thought that would end the rootkits, and somebody figured out how to make a credential provider rootkit on Windows 7, but they weren't able to make it put fake buttons here and get rid of the original buttons. So now you'd see 2 sets of buttons on your Windows XP login screen, Windows 7 login screen. So that's not as convincing as it could be, but still they were able to have fake ones, which will come from their wrapped credential provider, which is stealing the data. Anyway, if you do manage to get system-level access on the machine, you can then dump out the hashes with a tool like Kane or other tools, and you'll get these hashes. Now, the LM hashes are the old-fashioned system that was used before Windows Vista and is no longer used at all. So you can see they're all just a placeholder, all the same. The NT hash is what really contains the passwords. It's still pretty terrible, though. As you can see, the administrator, and let me make this a administrator and backdoor 2 all have exactly the same hash because they have the same password. This is amazing that Microsoft still does this. This is like, Linux fixed this in 1975. Microsoft still didn't get the memo. What's that, 40 years, 45 years? You're supposed to add some salt before you hash a password so that if 2 users choose the same password, they don't have exactly the same hash. But Microsoft didn't get the memo yet. So if you do that Go project, we crack Windows passwords, because Windows passwords are pathetically easy to crack. Even the newer, more secure ones are pathetically easy to crack. The older ones were laughable. Anyway, they are literally 1 million times easier to crack than Apple or Linux passwords, because Microsoft is 40 years behind in their cryptography for some unknown reason. Anyway, Microsoft, yes, they're unsalted hashes. Yes, Microsoft's hash algorithm is you change the password to Unicode and you run it through 1 round of MD4. It was written in 1993. It is so old, it is older than MD5. When they wrote this, MD5 had not been created yet. So they used MD4, which is, as you would imagine, even worse than MD5. The thing is, Microsoft has never updated it. They're still storing passwords exactly the same way that they did in the original Windows NT in 1993. It is hard to believe.
Why?
That's a very good question. I published articles and had trouble with Microsoft over this. It's a very good question. I don't know who's ever explained it. Maybe the password is complex enough. Yes, if the password is really like 20 random characters, then you're still okay. Then you still couldn't get in. But that's right. So you're correct. In principle, if you have like a long random character like generated from a password manager, which is what you should do, then it doesn't really matter that it's hashed. This hash is good enough for that. It's a good point. Anyway,
so you said password manager?
Yeah, you should use a password manager. Everybody should. That way, that's why I use long random passwords for everything. Now I've finally wised up. Every time I log in, you go to your password manager, it generates a random password for you. It's different at every site. I don't know any of them. They're all just stored in the manager. That's what you should do. Then nobody can steal your password.
They're vulnerable, especially the one that comes with the browsers like Firefox.
Well, sure. You do have a single point of failure now. You got to have it somewhere. So that's right. I'm using LastPass
Oh, that's good.
as a browser. Well, it's not really that different. It's an extension, and you know, it did get hacked at one time. So there is, of course, some repository. Otherwise, I'd have a list of paper I was carrying around and losing stuff. There's always something, but at least this way, I'm not trusting all the servers with anything that could be used at another server. Which is what I used to like, have a few passwords and reuse them. That's a really bad idea. So I finally knocked that off. And then for a while, I'd make up passwords and put them in the password manager. And I found out, I said, well, about time I just let the password manager make random passwords. And I think it was probably the Google Cloud that did that. Because if you use Google Cloud Windows machines, they make these random passwords and you can't change them. So you get used to handling just 15-character passwords or just punctuation marks. And it kind of gets you over this idea that you should be able to remember or type in your password. You just have to copy and paste it all the time, which is what you should do. Forget all about remembering passwords. So anyway, you get up these things and you can use them as pass-to-hash attacks without cracking them, or you can and you can harvest them with PW Dump, or the pass-to-hash toolkit can steal them and pass them on as authentication. PW Dump, this injects a DIL into the local security authority subservice. Microsoft doesn't want malware stealing password hashes, so you have to elevate all the way to system privileges to get it. And so this injects a DIL into the security subservice to get it. You have to do some fancy things to get it. And also, by the way, it's encrypted with another layer of encryption called Ciske Encryption, which is symmetric reversible encryption, and that key is hidden in the registry. So Microsoft regards that as adding security like Assault would, but it doesn't, because that was cracked decades ago and everybody can just undo that encryption, so it doesn't really slow you down very much.
Which one was cracked? That's why I asked for the.
What's that? It's called Ciske. Yeah, it's called Ciske Encryption. And the only, oh yeah, it's been reversed a long time ago. The only thing Ciske Encryption does is it protects the passwords while the machine is turned off. If the machine is turned off, then the Ciske Encryption gets in your way and you can't get the key. That's right. Getting it from running system is how you do it. Anyway, PW Dump is another way to do it. This injects something into LSASS. They both inject malicious DILs into the security authority LSASS process, which is how they service, which is how they get the passwords, because none of your code is allowed to directly access the passwords. Anyway, there's other variants here that will do this. Many ways to call system functions. These are, of course, undocumented. Notice how they have names like System Function 25 and System Function 27. That's when you know this was an internal Microsoft function that nobody else was ever supposed to use. But since you can just use WinDebug and look in the kernel, they can't really hide anything from you for long. Anyway, so here's password dumps grab hash, calling all these DILs, and then calling System Function 25 and System Function 27. All right. The pass-to-hash toolkit gets the hashes and then uses different API functions. It uses LSA, enumerate, logon sessions, and things like that. There's quite a few Windows API calls that have to do with manipulating password hashes. And these different malicious attack tools use different ways to do it. Anyway, let's take a look at the Chapter 11 cahoots, which are here. All right. And there we go. All right, good. All right, I'll give it a few more seconds, see if we got any more coming. All right. So, what's poison ivy? Right, a remote access tool or remote access Trojan. All right. Which one puts malware in the resource section? That's a launcher, which is actually two programs packaged together. You have a program, and then it has another whole program in its data section, which it then launches. All right. In the resource section, often. Okay, which one causes the infected machine to send a SYN back to the attacker? That's the reverse shell. You make an outgoing call to the command and control center. All right, which one of these is no longer included in Windows? Well, which one no longer runs in Windows? Some of these are not part of Windows, but anyway, Gina's over. Gina's been replaced by Credential something or other. All right. Okay, which one puts a DIL in LSASS? Many of them do. I think all of them do. That's how they mostly all work. All right. So it's a Kahoot. I bet that's you.
No, it's a Kahoot.
It's a Kahoot. Okay, excuse me. All right. And WITB is a double two-time winner, and M. Hino is a winner. All right. Well, I think that's enough. I think I'll let the rest of this chapter go for next time. We've got plenty of time, and I encourage people to do the projects. And if you feel like doing Go, it's good, clean fun. And I will, there'll be more of these Go projects coming. Let me see if I can figure out how to get there by browser. So we're on 126. There's more of these things coming. The next thing I'm planning to do is steganography, because when I got this Go stuff working, I figured out how to do bytes and strings, and then I figured out how to do file IO and process something byte by byte. So I used Caesar cipher, and I'm going to have XOR cipher, and then I realized you can just as easily start doing steganography, where you modify the bits in the pattern and hide data in there. And so that's where I'm planning to go. There'll be another couple of these, and I make it's a CTF for the scoreboard and everything. But if you want City College points, you should catch images. Anyway, any questions about anything? All right, looks like here comes a chat. Okay. For the PayCalc Pwn, yeah, control of my RIP with NX enabled. How do I run rock gadgets on the stack? Okay, let me stop the recording, and then I'll keep talking about that. I just that's a fine question, and I can say a few things about it just right now. This thing to do. You're the first customer